Hi everyone, welcome to this presentation covering data warehouses on AWS. My name is Gal Barnea and I lead Amazon Redshift's database engineering team for AWS. In this session, we'll talk about modernizing your data warehouse. And when it comes to migrations, it's all about speed of innovation. By migrating to a modern data warehouse in Amazon Redshift, you'll be able to create actionable insights for your users. You can answer your internal and external customers' requirements faster, introduce new datasets, and enrich existing ones quicker, and open up new ways to analyze all your data. You'll be making your customers' experience better, and you can evolve your product in more meaningful ways to allow your business to continuously make progress and grow. Today we'll discuss the reasons customers and potentially your own company are looking to migrate from your legacy data warehouse. We'll share best practices. We'll highlight new features with Amazon Redshift that can help you accelerate your migration and guide you on how to start your migration today so you too can benefit from the value of a modern data warehouse. If you have a legacy data warehouse, you probably know that many times data from different LOBs, lines of business, and source systems is siloed from sharing or querying. With a modern data architecture, you can combine all your data and query it in place to generate meaningful cross-organizational insights. The Lakehouse approach allows you just that, a data warehouse that lives with one leg in the data lake and allows querying its data in place with no additional processing needed. And it's not just that. A modern data warehouse needs to answer a variety of requirements. Your users, for example, may be looking to perform predictive analytics that takes advantage of machine learning algorithms and allows them to generate forward-looking reports, not just historical ones, or operational analytics, while having the ability to distribute their insights through embedded dashboards. Your data administrators and owners want a single data catalog that is comprehensive and searchable, and industry-leading security and compliance that don't require additional costs. And your data engineers look for a broad ecosystem to ingest and transform data and automate infrastructure management through code. Why migrate to Amazon Redshift? Let's start by taking a look at some of the customers that have taken advantage of Redshift. NTT Docomo, for example, the largest mobile communication company in Japan, have migrated over 10 petabytes of data from an on-prem data warehouse to Redshift, where they have achieved 10x performance improvement over their legacy systems. Fox, a major media and broadcasting company that generates billions of transactional events per day, coming from various third-party sources. The Lakehouse approach has enabled Fox to query data where it lives using Redshift Spectrum. And Warner Brothers. Elastic Resize helps them scale up and scale down clusters based on their peak usage. They also use workload management and set query monitoring rules to optimize their resources and maximize their throughput. Finally, they can leverage the latest RE3 instance types for the best-in-class performance. Customers choose Amazon Redshift for three aspects. First is our Lakehouse architecture. Redshift Spectrum has enabled customers to query the S3 data lake where it lives. As more customers want to query all their data, we've expanded the capabilities to query relational databases using federated queries and allowing customers to combine their warehouse data with their operational data. Second, Redshift provides fast performance at any scale. Whether you are just starting or an advanced customer, Redshift provides performance and scale to your needs. Our RE3 nodes have enabled best-in-class performance to where they can now scale compute and storage independently. Aqua is built on RE3s and provides a new hardware-accelerated cache to boost your queries. And finally, we have helped customers get the best value and bang for their buck. More importantly, we make your costs and their costs predictable, even as your workload scales. When we look at the innovation that the Redshift team has been driving in the last few months, we've identified 3 focus areas. The first one is data lake and further integration with other AWS services and partners. The second one is performance at scale, from out-of-the-box query tuning to customers with strict SLAs that have multiple petabytes. And the third one is keeping it cost-effective and predictable to get the best value out of Redshift. In our first investment area, Lakehouse and AWS integration, we're expanding to new use cases with customers to solving machine learning problems such as predictive maintenance or fraud detection using Redshift data. We will enable customers to share their data across clusters using live data with our new data sharing feature. In our second investment area, performance and scale, we continue to build on the R3 architecture, combined with the managed storage, an architecture that Aqua leverages to boost query performance. We've enabled customers with concurrency scaling with reads and introduced our new write feature that will be coming soon. We will also automate many of the requirements for table optimization to get the best performance out of Redshift. And finally, in order for customers to get the best value out of Redshift, we have made updates to the automatic workload management so that our customers get the best throughput and bang for their buck with the existing configuration. We also have a built-in new feature, cross-AZ cluster recovery. Intuit, for example, migrated to Amazon Redshift from Microsoft SQL Server with great success. Previous solutions based on Microsoft SQL Server couldn't scale with the explosive growth of data, and it required significant manual effort and cost, which resulted in delays in insights. Intuit migrated to a solution based on Amazon Redshift. It scales more than 7x the data volume with zero effort and delivers 20x the performance, which has led to 90% reduction in time to insight and a 66% reduction in cost. And Intuit is not alone. With tens of thousands of customers, Redshift continues to be the most popular cloud data warehouse. Thousands have successfully migrated their workload to Redshift. Magellan Health, for example, was running their analytic platform on-prem using an IBM Netezza data warehouse. They were not able to meet business needs with this legacy technology, causing revenue loss. Magellan Health decided to modernize their analytics platform by migrating their workloads to Amazon Redshift. And that has helped the company provide near real-time reporting to its users, reduce costs, and deploy AI/ML tools to derive relations between petabytes of data. And they chose AWS because of our proven expertise in supporting data analytics in the healthcare industry, as well as a comprehensive set of cloud services and scalable infrastructure. So you may ask yourself, how do we start? So you can migrate with your own capabilities, a self-driven migration. Okay, you can perform the migration on your own with our step-by-step guides, and you can reach out to AWS experts for assistance. But many of our customers also rely on our partners, and working with a new or existing partner can help ensure you're using the best practices and tools. This slide, by the way, includes a selection of SI partners that have a packaged Redshift consulting offer for customers to get started around their data and data warehousing migration journey. The partners listed here have been vetted to ensure that they not only have a deep Redshift expertise, but accelerators, tools, processes, and references to enable you to migrate from legacy environments risk-free and in the shortest amount of time. But the first step for migration is always the most challenging. Sometimes we find that organizations can get paralyzed if they can't figure out how to move every last workload. There's no need to boil the ocean here. For many of you, an iterative approach would be the right one and the one we encourage you to take. We often work with organizations to do a portfolio analysis to assess each application and build a plan of what to move short-term, medium-term, and last. This helps organizations get the benefit of the cloud for many of their applications quicker, and it really helps inform how to move the rest. From a tooling perspective, we start with data. And AWS provides the broadest range of tools for easy, fast, and secure data movement to and from the AWS cloud. I'd like to highlight two key services that we built specifically to help accelerate your migration. One is the AWS Schema Conversion Tool, SCT, and the other one is the AWS Database Migration Service, DMS. SCT accelerates migrations by automatically converting the source database schema and the majority of database code objects, including views, stored procedures, and functions, to a format compatible with the target database. SCT can also scan your application source code for embedded SQL statements and convert them as part of a database schema conversion project. During this process, SCT performs cloud-native code optimization by converting legacy Oracle and SQL Server function to their equivalent AWS service, thus helping you modernize the applications at the same time as migrating. Once schema conversion is complete, SCT can help migrate data from a range of data warehouses to Amazon Redshift using built-in data migration agent. Just as important, any object that cannot be automatically converted is clearly marked so that you can manually convert them to complete the migration. DMS is the second AWS service that helps you migrate databases to AWS quickly and securely. The source database remains fully operational during the migration, minimizing downtime to applications to rely on the database. DMS is highly resilient and self-healing. It continuously monitors source and target databases, network connectivity, and the replication instance. In case of interruption, it automatically restarts the process and continues the migration from where it was halted. Multi-AZ, multi-availability zone option, allows you to have high availability for database migration and continuous data replication by enabling redundant replication instances. With DMS, you can continuously replicate your data with high availability and consolidate databases into a petabyte-scale data warehouse by streaming data to Amazon Redshift and Amazon S3. We designed AWS Database Migration Service, DMS, to be simple. You can get started in less than 10 minutes, and just as important, you can use DMS for free for 6 months. Let's talk a little bit about best practices, ones that we've received from our specialist team. Sizing of a Redshift cluster based on existing legacy data warehouses is always a challenge, and many consider it more of an art than a science. So in order to help those customers, we've built a sizing widget in the Redshift console. As you can see here, the sizing widget allows an interactive, more intuitive way to size a cluster based on whether your data is compressed, whether your data is added in time order, added every week, month, or day, and the amount of data that is frequently queried, meaning hot data. Give it a try. To help you improve performance and decrease the operating costs for your Amazon Redshift cluster, Amazon Redshift Advisor offers you specific recommendations about changes to make. The advisor develops its customized recommendation by analyzing performance and usage metric for your cluster. These tailored recommendations relate to operations and cluster settings. To help you prioritize your optimization, Advisor ranks recommendation by order of impact. Here's a collection of tips and tricks from our specialist team that has worked with customers migrating for years. I won't discuss each and every one of them, but I do want to call out a few. One example, LLBs, large objects that hold large objects such as images and PDFs, can be still ported with the help of SCT to S3 with a link or a pointer stored in the Redshift tables, or using materialized views to help migrate complex queries and provides faster query performance for BI dashboards. When migrating your ETL data processes, there are several paths you can take. One is modernizing the modernization approach with native AWS services such as AWS Glue and Amazon EMR, while another one, just as compelling, is to leverage capabilities of our third-party partners and products such as Matillion, Informatica, and Talent that support Redshift natively and allow you to change your target type and point your workflows to a new cluster endpoint while maintaining all your transformations and business logic that have been built into them by the team. For a Vertica migration, for example, you can simplify ETL queries, creating user-defined functions, UDFs, with the same signature as Vertica-specific ones used in your ETL queries. For an Netezza and Greenplan migration, you can take advantage of the native bulk export for fast data onboarding into your data lake or into your Amazon Redshift data warehouse. And as for an Oracle or SQL Server migration, it's worth mentioning that OLTP workloads can also be migrated to an AWS RDS or Amazon Aurora cluster. And you can query it from within Amazon Redshift cluster endpoint using federated queries, which distribute the computation directly into the remote operational database. It uses its parallel processing capacity to support running these queries as well. Now, let's look at Amazon Redshift and some of the innovation that the team has been driving that's focused on further accelerating migrations. Stored procedures are used to encapsulate logic for data transformation, data validation, and business-specific logic. By combining multiple SQL steps into a stored procedure, you can reduce round trips between your applications and the database. Amazon Redshift supports stored procedures in PL/PG/SQL dialect, and you can include variable declaration, control logic, and loops, allow raising errors, and support security definer and other features. You can create stored procedure to perform functions without giving a user access to the underlying tables with security definer controls. You can find more information about creating and running stored procedures in the Amazon Redshift Database Developer Guide. Many customers already use Redshift's table-level access control for data in Redshift and also want the ability to control access at a finer granularity. With column-level controls, you can control access to columns without having to implement views-based access controls or use another system. It allows enforcing security for sensitive data, like PII or PCI data, by granting and revoking column-level privileges to a user or a user group. In this example, we grant permissions on sensitive data to the authorized user. When the authorized user tries to access the table through a select star or querying the columns directly, it succeeds. However, an unauthorized user can't access the data by running a select star, but can access the permitted columns. In September, we announced support for up to 100,000 tables and 10,000 stored procedures. Until then, customers with more tables had to split their tables across Redshift clusters or move some tables to Amazon S3. Now, customers can migrate their workloads without splitting or moving their tables. This capability is automatically enabled for all supported node types for existing and new clusters, so customers don't need to change their workloads, data ingestion, or their applications to take advantage of this feature. This limit, by the way, includes user-defined temporary tables and temporary tables created by Amazon Redshift during query processing or system maintenance. Amazon Redshift launched native spatial data processing support in November 2019 with a polymorphic data type, a new one called geometry, and more than 40 SQL spatial functions. Amazon Redshift supports over 30 new spatial functions such as validation, simplification of geometries, and new spatial relationship like crosses and contains property. Furthermore, Amazon Redshift enhanced the spatial functionality with multiple capabilities such as ODBC, JDBC support for geometry data, support for importing spatial data in shapefile format, and spatial join performance improvement. Now, spatial data can be ingested from shapefiles stored on S3 by using the copy command. And large geometries can be simplified on ingestion time. The JDBC ODBC driver support for geometry data type enables seamless connection to a spatial ecosystem, and customer and partner applications can natively consume spatial data now. We also introduced native support for time and time-tz data type. Time data type stores the time of day without the time zone information, and time-tz stores the time of day including the time zone information. This new data type builds on existing support in Amazon Redshift for date, timestamp tz data types that can store data in date and time values. The new time data type enables you to create columns in Redshift tables that can store only time values. And you can also use various date and time SQL functions to process the time values in Redshift queries. Amazon Redshift supported reading JSON file formats using Redshift Spectrum, but customers also requested the ability to query nested data such as JSON natively. At reInvent 2020, we've introduced a new data type, Super, that will support these nested data formats such as JSON and enable customers to ingest, store, and query nested data natively in Amazon Redshift. JSON formatted data can be stored in Super columns and can be queried through an easy-to-use SQL extension that is powered by the Particle language, a query language which is designed to seamlessly process structured and semi-structured data. Particle extends the standard SQL language to declaratively express and process nested and multi-value data, and is being actively adopted by multiple AWS services, such as Amazon S3 Select, Amazon Glacier Select, Amazon Quantum Ledger Database, QLDB. In this example, for example, you can see the usage of the dot notation to query the value of an attribute by using the table.column construct. Customers have also asked us the flexibility to integrate with other AWS partners and services. And with Lambda user-defined functions, we enable customers to use an AWS Lambda function as a UDF in Amazon Redshift and invoke it from Redshift SQL queries. This functionality enables you to write custom extension for your SQL query to achieve tighter integration with other services or third-party products. For example, you can write Lambda UDFs to enable external tokenization, data masking, identification or de-identification of data by integrating with vendors like Protegrity, and protect or unprotect sensitive data based on the user permissions and groups in query time. Amazon Redshift continuously monitors user workloads and uses sophisticated algorithms to find ways to improve the physical layout of data, to optimize query speeds and tune queries. By using automation to tune the cluster, customers can decrease administrative costs for Amazon Redshift while getting the best possible performance. Automatic table optimization selects the best sort and distribution keys to optimize performance for the cluster's workload. If Amazon Redshift determines that applying a key will improve performance, these tables would be automatically altered without requiring administrative intervention. Additional features like automatic vacuum delete, automatic table sort, and automatic analyze eliminate the need for manual maintenance and tuning of Redshift clusters to get the best performance for new clusters and production workloads. In order to get even more value out of Redshift, we have improved the workload management by leveraging machine learning algorithms to get more query throughput for your high priority workloads. This means that you can run more queries without adding additional nodes or costs to your cluster. We're always looking for ways to tune queries to get maximum speed. And with Materialized View, automatic refresh, and rewrite of Materialized View, queries can benefit from existing Materialized View and can use them automatically without needing to change SQL. Still, these automation features are all optional. If you prefer to have fine-grained control over performance and tuning, you can continue to do so. So you probably ask yourself, that's all great, but how do I start? Here's a few recommended links to get you started. You can visit the Redshift homepage on the AWS website. You can also request a briefing and connect with an AWS migration expert to provide you with guidance on your migration path. You can browse FAQs and the Big Data blog that hosts many of our success stories around migrations. You can also look up a variety of scripts and tools that simplify management of Redshift on GitHub. You joined the AWS Summit to learn, and you can keep the learning going after the summit with resources from AWS training and certification. We offer many free and on-demand digital courses, as well as virtual instructor-led training. AWS experts will help you or your team learn to build and validate your data analytics skills. When you're ready, prepare for an AWS Certified Data Analytics Specialty exam, which validates your skills and provides an industry-recognized credential. For more information, visit us on our analytics training website and be sure to check out our AWS Ramp-Up Guide to learn more. I want to thank you for joining me today, and feel free to reach out to the team or myself for any additional questions.